Hey guys, now for the next lesson in our factoring extravaganza. So I'm going to use the learning target to kind of tell you why the strategy that we are going to do works. And there's a couple things I need to remind you. So first of all, I need you to remember what a trinomial is. I think that part we've definitely got down, right? We're going to be factoring something that has 3 terms. That's why this is a trinomial. Remember the reason that it's quadratic is because the highest exponent, that very first term right there, has a 2, a degree of 2 in that term. And then finally, the other thing we need to remember is this part about a equaling 1. So remember that when we have a trinomial written in standard form like this, the biggest exponent, or the highest degree, I should say, to the smallest, that this number 5 is A, that number 40 is B, and in this case, this constant by itself is C. So in the previous examples where we were able to factor quadratic trinomials, we were able to do it a little more easily because A was equal to 1. I'll remind you of one of those examples from a previous lesson. So remember previously, because A was equal to 1, remember that number in front of the x squared, we were able to do this really easily. Please excuse the traffic outside my house. Remember we were able to just kind of open up those binomials, and we made ourselves our table where we had to figure out what did we multiply in order to get C, in this case was 5, that we would add to get B, which in this case was 6. And we know, for example, that in order to get 5, you could do 1 times 5. And it just so happens that 1 plus 5 gives you 6. So you could just take the binomials. You could say it's x plus 1 and x plus 5. Hopefully this is ringing a bell for you. Okay, so again, the reason we were able to do that so easily is because A was equal to 1. Well, in today's examples, obviously A is not equal to 1. That's what this little A with the equal, the little slashy thing means, not equal to. Because A is actually equal to a 5. So we're going to take advantage of what we learned about with greatest common factors yesterday and to see if maybe that makes it a little bit easier for us to be able to factor this expression. So remember in the previous lesson, I told you from now on, your very first step, always, 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 is going to be to check for a GCF. So I'm going to look at all 3 of those terms, and I'm going to see, is there something that I can factor out of all 3 of them? And so if I look at the numerical portion, I notice there's a 5 and a 40 and a 100. Every one of those is divisible by 5. We do have B's in these first 2 terms, but since we don't have a B in the third term, that means we can't factor out any B's. So in this case, our GCF is going to be 5. So what we're going to do is we're going to figure out what the GCF is. We're going to do step 2 exactly like we did yesterday. We're going to factor out the GCF using the opposite of distributive property, or like undoing distributive. So remember what that looks like is we're going to put that 5 out to the side. And then let's see what we have left over in the rest of the binomial once we get done. So if we had a 5b squared and we factored out the 5, then all we're going to have left is the b squared. Here we had a 40b, 40 divided by 5, because we factored out the 5. So 40 divided by 5 means that we're going to have 8 B left over, because remember when we're factoring, we're technically dividing. Then I look at this 100. 100 divided by 5 gives me 20. And because that was a positive divided by, or a negative divided by a positive, it's going to be a minus 20. So exactly like we did yesterday, we're going to determine what the greatest common factor is, if there is one. Although I'll go ahead and tell you for today, there's going to be one. We're going to factor out that greatest common factor using distributive property. And looky what I got here now. Left over in the parentheses is... So now I've got myself here, and for lack of a better term, I'll call it like the leftover, right? Now I have a quadratic trinomial, but then A is only 1. So now I can go back and do some more factoring because I can do it the way we already know how to do using the table. So now we're gonna factor, and this isn't a great word, but I'm going to say leftover, because that's kind of what's left, right? Factor the leftover. Oops, bad handwriting. So what I've got there in blue, using that table method. And remember the table method is I need to figure out what can I multiply to get C. So in this case, C is going to be negative 20 that I can add in order to get B. So in that case, that's going to be 8. So let's figure out all the things I can do to multiply to get 20. And keep in mind, it's important that that's a negative 20. So I could do 1 and 20. Obviously, one of them needs to be negative since that's a negative 20. So I could do negative 1 and 20 or positive 1 and negative 20. Neither of those adds up to B. I can do 2 or negative 2 and positive 10 or positive 2 and negative 10. And look, voila, if I add together a negative 2 and a positive 10, that also gives me 8. So remember what you do is you pop open those binomials. The only way I can get a b squared is if I do a b times a b, and then I take my table values, so it's going to be b minus 2 and b plus 10, because remember the numbers from the table are going to come down here, and now they're going to be there in the binomials. And the last thing you want to make sure that you don't do is don't forget the GCF. So that GCF that I factored out earlier, he's still there. Okay, now he's not really doing much. He's kind of just chilling out there because we factored him out, but he's still technically there. So you still need to bring him down to be part of your final answer. So the fully factored form of that polynomial is going to be 5 times b minus 2 times b plus 10. Okay, so the next example, again, my very first step is always going to be to look for a greatest common factor. I'm not going to write out the steps this time because you've got those. So if I'm looking at my 3, if I look at 30, and if I look at 72, I can see that all of those are divisible by 3. So that means that my greatest common factor, I'm going to factor out a 3. So now let's see what I have left over after I factor out that 3. So I had a 3x squared. I factored out a 3. So that means all I have left now is an x squared. I did have a negative 30. Negative 30 divided by 3 is going to give me 10. And because of that negative, don't forget that that needs to be a minus 10. I didn't factor out any x's, so I still have an x there. And then 72 divided by 3 is 24. So now that I've factored out that greatest common factor, I now have a quadratic trinomial where a is equal to 1. So that means I can use my table method. So I'm trying to figure out what can I multiply to get c. So what can I multiply to get 24 that I can add together to get b. So in this case, that'll be negative 10. So because that 10 is negative, I know I'm probably going to have 2 negative numbers. So let's figure that out. So what can I multiply to get 24? So I could do negative 1 and negative 24. Obviously, that doesn't add up to negative 10. I could do negative 2 and negative 12. That's not going to give me negative 10. I could do negative 3 and negative 8. That doesn't add up to negative 10. I could do negative 4 times negative 6, and then voila, right? Negative 4 and 6, if I add the negative 4 times negative 6 multiplies to give me the 24 I need, and then also negative 4 plus negative 6 adds to get the negative 10 that I need. So now that I have those 2 numbers that I need, so that negative 4 and that negative 6, you know what to do. So I'm going to pop open those binomials down here. The only way to get an x squared is obviously if I factor it to make it an x times an x. And then I'm just going to pop in that -4 and that -6. And then don't forget again about that GCF that's kind of chilling out there being useless, but he is still part of the answer there. Okay, so you've got a -3 times x minus 4 times x minus 6. Okay, so now I've done a couple examples for you. I want you to try this one. So pause the video, try it out yourself, and then check yourself when you get done. I'm going to assume that you've already gone ahead and tried it out yourself. So my first step is that I'm going to look for a greatest common factor. I see that 3, 27, and 42 are all divisible by 3. So that 3 is going to come on the outside, and I'm going to factor it out of there. So I had a 3n squared after I factored out a 3. Now I've just got n squared. I've got 27n, or 27, I divided it by 3 because I did 27 and factored out a 3. So what's left over is a 9n, and that is subtraction because it's a -27. And then 42 divided by 3, so if I factor a 3 out of that 42, that gets me a 14, and it is a positive 14. So now I've got myself a trinomial in my little leftover portion here. A is equal to 1, so now I can use the table. So what do I multiply to get C? So what do I multiply to get 14? Then I'm going to add to get B. In this case, it's -9. So again, because I'm going to add two numbers together to get a -9, and because a negative times a negative is a positive number, I know that the two numbers I'm looking for are most likely going to be two negative numbers. So I'm going to try -1 times -14. Obviously, those don't add to -9. Then I'll try a -2 times -7, and then there we go. Because -2 plus -7 also equals to 9. So I know that now I'm just going to pop open those binomials. The only way to get an n squared, of course, I'm going to factor that n squared into an n times an n. And then I'm just going to pop those two numbers in there, that -2 and that -7. So it becomes n minus 2 and n minus 7. And then don't forget about the GCF that's just been chilling out there, not really doing much, but he's still technically there. So your fully factored version is 3 times n minus 2 and n minus 7. I should note for the record also, because I get this question from a lot of people, it doesn't matter what order you put those in. You just as easily could have said 3 and then n minus 7 and then n minus 2. So it does not matter if yours was in a different order for mine. That's fine, because it really means the same thing.